replicate it across the whole network. We can make every node agree on this chronological order of transaction. And basically, you need to trust no one, which makes blockchain technologies a trustless setup. And this is, in fact, a property which is very cutting edge with blockchain, which is very interesting, and that justify a lot of the hype surrounding this this area of technology and research nowadays. So this use case makes it very good for things like payment systems, also value holding, notarization. So basically what I mean by notarization is making sure that at some point in time, some data was validated by a party. That's why you would go to see a notary traditionally. Well, with blockchain, you can do that without requiring a third party. And also when you need to have a public proof or something like, for example, ownership of something or knowing some data or whatever you name it. So for this kind of situation, blockchain are very handy. However, blockchain is not a one-size-fits-all kind of situation. You have also some use cases which are not, for which the blockchain technologies are not well suited. For example, sharing big data. Well, the data structure of blockchain is not optimized at all for storing big amount of data. So you should not rely on blockchain to do that. Also, because blockchain is very open by nature and transparent, which makes it possible for anyone to check everything, meaning that you, once again, do not need to rely on a third party to have some trust on anything that's present on the blockchain. This means that privacy is not something which is very easy to achieve on the blockchain network. However, we want to have privacy because it makes the platform much more interesting. So that's why it's a very trendy research topic. And also that's why Gaurav will be discussing this topic later in the talk. But keep in mind so far that transparency and privacy are in some sense counterintuitive and really difficult to have the two of them all together at the same time. So now a few words about cryptocurrency. We can think that cryptocurrency and blockchain are the same thing, but that's not true. Cryptocurrency is just a very successful and useful application of blockchain, and in fact was the test bed and the first, well, the blockchain technology was designed, in fact, to support cryptocurrency. I assume you all know Bitcoin. The Bitcoin, well, it was the first introduction of blockchain. So the two are very intertwined, but are not the same thing. So here on the slide, we list a few cryptocurrencies, with once again, the most famous one being the Bitcoin. There are also what is called stable coins. Stable coins, basically, as the name suggests, is a cryptocurrency for which the exchange rate tends to stay constant, which makes it more desirable as an exchange tool, whereas the Bitcoin, for example, is better suited with its volatility to be a store of value, but not really a money, where stablecoin try to become a useful money. Now I'm going to say a few words about smart contract. So this is a whole new paradigm which takes advantage even further of the trustless nature of blockchain. And basically the idea is to say that exchange of money, which was the first application of blockchain, is just a subset of what can be done when you have a trust party that a third party that you can trust. And basically, the idea of smart contract is a generalization of that, saying that anything that would need a third party, like for example, notarization or conditionally moving an asset with some condition, well, anything that's closer to that can be implemented into a smart contract. So technically, a smart contract is a language, yes, programming language, which is Turing complete, naming in easier terms that you have conditions and you have loops. And basically, the peculiarity of this language is that it can implement any business logic and transfer assets when conditions are met. And this makes the blockchain paradigm extremely powerful because it can it makes it so that there isn't any need for third party anymore. As long as you can program the business logic of your contract, then you can get rid of the third party, and that's very powerful. Now I'm going to list some well-known application of blockchain. So and I'm going to start with the Bitcoin, which was the third blockchain created, as I already said. It was created in 2008 by someone called Satoshi Nakamoto. So this is a pseudonym. No one knows who is Nakamoto. So it's a cryptocurrency. As I already said, basically the aim of that is to be used as a money. This blockchain is permissionless, which means that anyone can get involved into the blockchain and no authority needs to accept you inside the blockchain. So it's very open by design, which is very interesting. And it is based on what is called the UTXO model. So what it means is that it's unspent transaction output model. Basically, it's an implementation of the object taking the value in the blockchain. This object looks like a coin, basically. So when someone pays you, in some sense, they send you a coin, and then to pay you, you can reuse this coin. That's what is meant by the UTXO model. The Bitcoin mining is well, I'm assuming you've all heard about crypto mining and Bitcoin mining. So this operation is required because of what is called the consensus algorithm and protocol of the Bitcoin blockchain. So what is the consensus algorithm? Well, it's just the algorithm which is needed to make sure that everyone on the network agrees on the order of transaction. And because the agreement about the order transaction is so central and important in the blockchain technology, the consensus mechanism chosen by a blockchain is very important because it provides this feature. So in the context of Bitcoin, this algorithm is called proof of work. And proof of work basically implies that each miner on the network needs to solve a cryptographic puzzle, which is very complicated and is rewarded when they succeed in doing so. So on Bitcoin, they are rewarded by receiving one transaction of Bitcoin. So that's an incentive mechanism. One downside of proof of work is that it's very power intensive and energy consuming. So it's very critical in terms of environmental impact, especially at this time when it's become so a so critical issue. So that's why some other consensus algorithm mechanism are being studied. So the Bitcoin, to get back to it, has been a real breakthrough because it was the first implementation of blockchain, but its scripting capabilities are very limited. So basically, you just can send money and receive money and not much more than that. And a big advancement on top of that was the introduction of smart contracts, which were performed on Ethereum, which was created by Vitalik Buterin in 2015, and which is a permissionless blockchain. So just like Bitcoin, anyone can join freely the network. No one needs to agree that you join. And it's on the other hand here, the model of the blockchain is account-based, meaning that unlike Bitcoin, where you have UTXO and it's like exchange of coins, here basically each user of Ethereum, it's like you have an account which has some amount on it. It's much more like a bank account. And so when the Ethereum network is running, it modifies the account of the value stored in the account of different users, basically, instead of exchanging coin. That's the difference. Now, a few words about the smart contract in the Ethereum context. So basically, we have a word state. So that's the value everyone on the network needs to agree upon. Is a data structure in the form of a key value pair. This key value pair could be, for example, the number of coins some people owe, or stuff like that. And this key value pair can be modified by the smart contracts which are stored on the blockchain. We have the Ethereum virtual machine, which runs on the chain by each miner of the Ethereum network. They run compiled bytecode, which need to be programmed. So you program a smart contract, then you compile it to EVM bytecode, and then you upload it. And when this code is uploaded, it is run by all the node on the network. This language is bytecode is Turing complete. So as I already said, meaning that basically it can use conditional branching and loops in the code. When the smart contract is deployed, it's by uploading the bytecode by some user of the network to the network. And since it's Ethereum is based on a bytecode instead of a language, anyone who can write a compilator from some language to this bytecode can create a new language. But the most famous one is Solidity. So most of the smart contracts are written in Solidity for Ethereum. A very interesting and higher level application of smart contracts in Ethereum was what is called a decentralized autonomous organization. And basically, is any kind of organization not requiring central governance, but having its different laws implemented into smart contracts, which means that they are fully autonomous and automated, and you do not have to have external regulation running them. This leads to a famous saying in blockchain, which says the code is the law, meaning that, well, indeed, everything that is programmed in the blockchain becomes the law of this organization. This led to an interesting anecdote with the Ethereum blockchain. So at the beginning of this, the Ethereum project, they created a DAO, and there was a bug into it, which allowed some hacker to steal a huge amount of money out of the network because they exploited a loophole in the DAO. And there was at this point, there was a split in the Ethereum community with some people saying, okay, there was a bug, but that's the spirit of blockchain. Once the code is deployed, you cannot change it, you cannot alter it. That's the strength of it. So we need to accept that there was a mistake, and we need to move on with this mistake in the in the history of the blockchain. And there were other people who said, no, it was a bug, a very big bug, it's problematic. We need to go back in time. All agree to go back in time and then rewrite the history before we introduce this DAO. And so this led to a split in the Ethereum community, with the former forming the Ethereum Classic, which is a new blockchain, basically. Now, I'm going to say a few words of Hyperledger. So this is a set of blockchains developed by the Linux foundations, which are very business oriented, in the sense that they are permissioned. Basically, a permission blockchain is a blockchain for which you need to have some authority that grants you access to the blockchain. So it's very different from permissionless blockchains like Bitcoin or Ethereum. So it makes them much more suitable for business use cases. In the design of Hyperledger, we have a plug and play approach for the consensus and identity management. So this flexibility is very interesting because you can read different. You can decide. You can have different feature, and you can make compromise to target properties that you need for your own application, which wouldn't be that interesting from someone else's application. So that's an interesting approach. So it doesn't have a cryptocurrency because it's permission. It doesn't have to rely on mining. And so there is no need to have an incentive which would be built based on the cryptocurrency. However, the smart contract paradigm is supported, and the default language of the platform is Go. So when you wanna write smart contracts for this platform, you tend to do that in Go, even though some other languages are supported. So another application of blockchain is the Internet of Things, better known as IoT, which is a very hot research topic nowadays. And the idea is to use blockchain as a backend for the IoT systems, so to decentralize the storing of data from all sorts of sensors. So yes, as an example, you can make sure that at this point in time, indeed the data from this sensor, like for example, temperature sensors in a factory, was indeed this value. And then you can use smart contracts to implement the business logic of these sensors. For example, let's think about a smart home. Okay, if the temperature is going below a certain value, then you can switch on the heating of the home. This can be handled by the use of smart contracts. So that's the idea. There are many applications. So we have airplane maintenance, smart home, smart factory, smart city, and a bit smart whatever. What I mean by that is that the huge hype surrounding the subject, and not all applications are very interesting. And I think that you should be all very critical when we say we're going to use blockchain, because it's not very useful, not always useful. And as I said in the beginning of the talk, it's not a one-size-fits-all technology. So maybe sometimes we should think about, is it really useful to move towards a blockchain for our application? because there is some overhead that comes with it. So, well, it's important to stay critical. Another application is the supply chains. So you can use a blockchain to improve the to easily track goods on the supply chain, and since the data is the same across the whole network of the supply chain, then it improves the traceability, because, well, you just have to check the history of the good into the supply chain, and you see its history, basically, and that takes advantage of a transparency feature of the blockchains. So now, after having a round introduction and a few application of blockchain technology, I'm going to hand it over to my colleague who will talk about privacy features and like development, what it is so hot topic in research, and why is it important in blockchain. So Gaurav, can go ahead.
Thank you, Danny. You can stop sharing the screen and I will open it.
Okay.
Hello, everyone. Thank you, Danny. And I think in the previous session, in the morning session, I see the keyword blockchain was also there. And here in this session, in the last few minutes with Danny, you have a good idea how blockchain can impact different business applications, different cryptocurrency applications, and in general, there are lots of applications which are being explored at the moment. They don't all fit to the blockchain, but in most of the cases, people try. And since this is current hype of this blockchain keyword, so everyone is trying to fit their application. In the following slides, I will try to cover what is privacy and how exactly we see that in blockchain context. And then we will take a specific blockchain, which is Hyperledger Fabric. We will explore the privacy issues and solutions in this particular blockchain. And if the time allows, we can go forward and we can see some permissionless blockchains. So the first thing that we see in blockchain is the most important concept is transparency. And transparency means everyone can see everything. And especially in permissionless blockchains, anyone can join the network. So there is no issue of permissions. And you can just see who is making a transaction, who is receiving this transaction, what is the amount of this transaction, and so on. So is it an application which we want to support in some real life examples? For example, let's say you want to receive your salary in Bitcoin, and you are on the top in some organization, and when the salary is distributed, everyone knows how much you are getting because you are getting the highest one. So this type of breach in the system that no one would like to do. We want to have a system where transparency is there, but there is some sort of privacy as well. So we want to store some confidential data on blockchain, but we want to make sure that there might be some people who can see that, but not everyone. In some blockchains, as Danny discussed, for example, in Ethereum, we have smart contracts, and these smart contracts are deployed on all the nodes in the network, especially full nodes. And whenever you are interacting with these smart contracts, that means you are trying to query some world state, or you are trying to uh, update some ledger data. That means you are interacting with the smart contract. You are submitting a transaction in the blockchain, and since these transactions are public, it means it limits the application of blockchain technology. So the interaction we would like to do in such a sense that maybe only limited participants can see. Maybe if there are only two parties, then maybe we would like to do it that way, that only these two parties can see this transaction. Depends upon which blockchain we are talking. So different blockchains have different issues, different solutions, and we will explore that later. Another important issue in blockchain is it seems to be GDPR incompatible. GDPR is General Data Protection Regulation, which is a regulation or a law in European Union. It says that being a customer or being a user of some services, some system, you have the authority to decide with whom you want to share your data. So that's a critical thing, and there are many companies who are getting punished for this, like millions of euros, because the usual system is whenever you are interacting with some services, they will store your data, they will sell it, they will analyze it for some business purposes, and this is always which we see already going on in the system. But at some point in the near future, in next 10-20 years, there might be a scenario that companies will ask you whether you want to share your data, and if they really want it, they will pay you for that. So this can be a good thing with this GDPR system. In this, especially, we are allowing customers or users to decide whether they want to be forgotten. That means they want, and the company or the organization or the service provider company, they will decide whether they allow them to use their data. In blockchain, you are submitting anything as a transaction, and if this is as a transaction, that means it is there forever, because the important property that we say, immutability, which makes sure that no one can change any data which is already in the blocks. So this is again a conflict with the GDPR system. So when we say transparency is a very good thing, but at some point we want some sort of privacy as well. So it seems that they are contradictory to each other, and some blockchains are trying to solve this puzzle, and they provide some different privacy solutions. So if we see what is privacy in the sense of blockchain, we will say that we don't want how much is being transacted. So we want to conceal the balance and transfer amount, and we want that who is transacting with whom. That means we want to anonymize the sender and recipients. Just to make sure here that anonymity is the most important keyword here, because without anonymity there is no privacy. There are many applications. For example, if you are browsing Facebook, Insta, or any other such website where you are not especially transacting some money, or you are not talking some transfer amount, that means the most important priority here is your identity that you want to hide. So we have to make sure that anonymity is maintained. In cryptocurrencies, there is a myth that cryptocurrencies are anonymous, because we see in Bitcoin, we claim that whenever some parties are transacting, the real identity is not being used in the transactions. So it is something like you generate a public-private key pair, and then you hash this public key, and it becomes your address. So these addresses are the parties who are basically exchanging the currencies or assets. So some people assume that this is anonymous. So we will talk about this in a bit. But cryptocurrencies are actually pseudonymous, and this pseudonymity with unlinkability becomes anonymity. And this pseudonymity, by the pseudonymity, what I mean, that means you are transacting every time with a different address, and you are making sure that no one can relate your previous transactions and next transactions, and so you want them to be unlinkable. For example, if there is some hacking group, let's say there is a one, let's say Fancy Bear, and this hacking group is doing some signatures or doing some leaving some footprints behind it, that I did this. So at the end, you can say the 3, 4, 5 transactions or the 3, 4, 5 thefts are being done by this particular group, because we know the pseudonym that they are using. So in these cases, we can say we can relate these different transactions because they are leaving behind some pseudonym. So these transactions are linkable basically. So multiple interactions with the system. If you are leaving behind something which relates to you all the time with the same identity, that means you are trying to be linkable, and which ensures that you are not anonymous. So why pseudonymity is insufficient? So for example, if you want to buy Bitcoin or some other cryptocurrency, there might be one way that someone transfers this to you, or there might be another way which you can buy it from the crypto exchange. So if you buy it from a crypto exchange, they might ask for your real identity. So ultimately, you are relating your real identity with the pseudonyms that you are using later for the transaction. In another way, when you are making this cryptocurrency transaction, you might be using the same browser. You made a transaction, and after that, you started using some social networking websites. So the IP address that you are leaking at the moment for making these transactions, this can be later tracked back to your identity, and your Facebook or your Twitter account can reveal who exactly you are. Another example, if you go to some shop to buy some coffee and you pay in Bitcoin or in some cryptocurrency, that means the guy who is receiving money from you, he knows exactly who you are. So these are different issues. And especially there are some companies who de-anonymize Bitcoin transactions. That is, chain analysis is one of them. So their main goal is to de-anonymize. So there are different, you can say, different methods by which you can disclose your real identity, even if you are using pseudonym. And in some cases, when we say anonymity is really important and this is something that everyone wants, there are several use cases where anonymity hurts. For example, in money laundering, in child pornography, cyber stalking, fraud and phishing, spamming, intellectual property violations, and many more. Whenever you are using this pseudonymity with unlinkability, that means you want yourself to be fully anonymous. That means you can do anything. So with these controls, there is always a debate, like whether this is a human right to be private, and to what extent. So these are different debates about privacy versus what to reveal. So what exactly we want from this privacy requirements for blockchain? We want the pseudonyms to be used all the time to maintain our identity privacy. The real identity should not be connected with that. The transactions are unlinkable to each other. We want to make sure about it. And the content of the transaction is known to the transaction participants only. For example, if we are exchanging through some coin exchange services, that means these coin exchange services know who is sending to whom. So this is also a breach in privacy. So the easiest solution that we do when you open a browser, you try to access any website, any secure website, you are always careful that I see HTTPS. And why this is suggested, because you see the data that you are exchanging with the server, this is encrypted. You use some TLS, SSL, and so on. With this encrypted data, you are always sure that the transactions that you are making, they are foolproof. And this is because you trust these encryptions in the hashings and the crypto primitives that we use here. So all the banking systems and everything works on this thing. So why don't we use that in the blockchain? So let's say just encrypt the data. So what's the problem? So the problem here is the smart contract that you are trying to, when you are trying to modify the ledgers, trying to make some new transactions to query or to update some ledgers. If they are encrypted, how the smart contract can decrypt it? Or the other validators in the system, in the blockchain system, who we call them miners, how they are making sure that the transactions are even valid. So this is a big issue, like direct encryption is not a solution. So what we see here in the following slides, we will see that we will take one particular example, which is a permissioned blockchain, which is Hyperledger Fabric, one of the most famous ones. And we will see what previous solutions have been already embedded here and what people are still working. So just a brief intro to Hyperledger Fabric. We have multiple entities here. We have the transaction participants. Transaction participants can be a reader who is just reading some data from the ledger. It can be, he can be a writer, so he is updating the ledger, or he can be an administrator who can instantiate the chain code. Only admin have this privilege, and he can change the channel configuration functions and instantiations of the chain code. There is a central authority, and this central authority is the party who is issuing these entities the certificates. And why we are talking here about certificates, because usually in Bitcoin, in Ethereum, anyone can join the blockchain, anyone can mine, anyone can make a transaction. Why we are talking here about certification authorities, because this particular blockchain is a permissioned one. So the specialty of permissioned blockchains is you have to make sure the participants who are allowed to make a transaction in the system, they are already enrolled with their identity. So this certification authority will issue you enrollment certificates. Then we have membership service providers. So usually when we are talking about a organization where there are many employees, different hierarchies and so on, so you would like to provide them different identities or different codes for their accessing. So there is a membership service provider who will manage stuff. In the blockchain framework, then we have endorsers. Endorsers are the peers who will basically receive your transaction, will make sure that you have some endorsement policies, and this is your choice, like to whom you want to make endorsers. And these endorsers will basically verify your transaction. Then these transactions are, when these transactions are signed by endorsers, this will be forwarded to the to the ordering services, and these ordering services will sequence the transactions and put that in a block. And then this block is being circulated among the peers to make further validations. And these peers are committers. And these validations are like, maybe there are two transactions who are trying to write the same ledger state. So this is not allowed. So one of the transaction has to be rolled back. So all the issues that we see in the distributed systems, concurrency issues or atomicity and so on, these all issues are still here in blockchain. So if anyone is really interested in distributed systems, blockchain can be a good learning for him. The last party that we have here is auditor. In many systems, we want one party. Let's say this is a government party, or this can be a third-party auditor who can make sure that everything is going well, so that we are not doing some money laundering or some other tasks with this blockchain system. With these parties in system, if you see this fabric diagram, we have 4 different organizations, and every user in the system will be using a Fabric SDK, which is the application by which you can prepare your transactions and signing your transactions and submitting it to the endorser. And then the transaction will be received by these peers, which are endorsers. And then endorsers will sign these transactions and forward it to the orderers. Orderers will use different algorithms to order these transactions and run the consensus among them. And then they will form a block, and this block will be finally circulated to peers. That's committed. And then we will add a new block to the ledger. So this is the system that Hyperledger Fabric follows, and this might be a bit different than the other blockchains that you might be studying, but the base is actually same. If you see the consensus algorithms, that means there might be parties who will be making sure that all the transactions in the block are valid, and then you are adding these blocks. The difference can be like, for example, in Bitcoin, you see the block can take like few minutes to get included in the blockchain. But here in Hyperledger Fabric, it can be very quick. So different consensus protocols, different strategies in different blockchains are being followed. So that's where it depends, like how much throughput you are producing with your blockchain, what security privacy features you are supporting with your blockchain. So different features, different applications. So what privacy issues we are particularly following in Hyperledger Fabric? So the first issue is transaction data privacy. Then we have state data privacy, chain code privacy, and the user privacy. And we will get back to one by one. The solutions that we have in Hyperledger Fabric, there are 3 solutions that are currently supported. One is with the help of channels. So this is a coarse grain access. Second, we have the private data collection, bit fine grain access. And for the user privacy, we have IDE mix. This is identity mixer. The concept is not very new, but it had been especially designed, like especially tailored for Hyperledger Fabric again, and then implemented, of course. So this the concept of channels that we see in Hyperledger Fabric is basically partitioning the ledger. And partitioning the ledger means whenever there are few parties in the system who wants to interact, who wants to exchange some transactions. Let's say one use case about supply chain, where there are some producers, suppliers, and distributors, and so on. and let's say they all are on the same blockchain, and you don't want that these transactions that we are making within the system, they are not visible to others. So you are restricting your transactions to see by any other party who is not included in the channel. Even they can be submitting their transactions to the same Hyperledger fabric, but in a different channel. So a channel is to make sure that the parties involved in this channel have a private conversation system. So what we will do, we will maintain a separate ledger for it. And of course, it's chain of blocks. They are submitting their transactions, approving their transactions blocks, and they are adding it to the chain. Then we have the ordering itself can be different in different channels. So there are 3 ordering services that are currently supported in Hyperledger Fabric. One is Raft, another one is Kafka, and the third one is Solo. So it depends which one you would prefer and in what scenario. For example, let's say Raft may have better throughput than Kafka. So maybe in some cases, use cases, you may prefer this one. So this is the scenario. And then we have the administrator who is going to create these channels, deploying the chain codes. So the chain code is basically a similar word for smart contract in Ethereum. So it's the business logic basically that your business wants to run on. And then we have some limitations in the system. The limitations are like endorsers, orderers, and everyone can see all the data. So all the channel participants will receive the transactions, will add the block to the ledger, but they can see everything. So this is one limitation of the channels. So what we can do? So if you want to protect your transactions from outside parties, channel is definitely a good idea. But if you want to make some transactions between some subset of these channel participants, then we have to think again. So to maintain this state data privacy, we have to make sure that any subset of these channel participants can communicate securely. And this communication means exchange of transactions. So what we are talking here, another solution that is provided by Hyperledger Fabric is private data collection. And this private data collection says the easiest solution, again, what comes to mind is encrypt the data at the application layer. But again, the validation is the problem. Like how the encrypted data can be validated if you don't provide them the key, and how the chain code can manipulate this data. So this is the biggest issue. So what the development community did in Hyperledger Fabric, they added a transient data field, and this transient data field is embedded in the smart contract. So the private key with which you are trying to encrypt, or any secret that can be embedded in this transient field, and then this transaction will be submitted to the. So this is being done by the user itself, and this transaction will be submitted to the endorsing peer. The endorsing peer will see, okay, there is a transient field. That means this transaction is not for everyone. So what he will do, he will store the encrypted data on the peer, and this particular transaction will be this particular data that we are sharing here will be shared only with specific participants in the system, specific peers in the system. So this private data is disseminated by peer-to-peer scenario rather via blocks. So in the usual system, what we used to do, when the transaction is endorsed by the endorser, it will go to the orderer will fit it into the block, and then it will be circulated back to the peer. But here in this scenario, what we want to share this specific set of data with a specific set of participants. So this will be done by the endorser in a gossiping scenario. So there is a protocol which is gossip protocol. So this endorser will talk to the parties with whom you want to share your data, and it will share that data with them. And then the hash of this data will be included in the transaction, will be given back to the orderer. Orderer will put it in the block and then will forward to the peer. So the peers who are going to verify this transaction, or the committers who are going to verify this transaction, are the ones who already have this data in their data store. So because the endorser already shared it with them. So they will verify it, they will validate it, and they will include it in the blockchain. So this is somehow you can make private transactions within a subset of channel participants. So this is one way to do that. Then we solved the issue of transaction data privacy with the channels. We solved the issue of state data privacy with this private data collection solution. And then we come to chain code privacy. Actually, it's quite straightforward, because when you are installing or instantiating the chain code, who is doing that? Actually, administrator is doing that. So he will make sure this chain code is shared with which endorsers. So you can decide the endorsers, so you can limit the sharing of chain code. So chain code privacy can be achieved directly by deciding the endorsers and the endorsing policy. So this seems easy. But the point is this sufficient? So what we covered till now is we try to make sure that a set of participants can exchange the transactions privately with the help of creating channels. Then we make sure that a subset of these channel participants can make sure that the transactions are can be performed between them. And this is especially required in the use cases. For example, in the same supply chain scenario, there might be some supplier who is making transactions with a specific vendor for a long time, and he might having some preferable rates for this party. So maybe they want to transact separately. They want to be in the system, but they want to transact for some particular transactions. They don't want to create a new channel, of course. Otherwise, they can do that. But if any party wants to submit a transaction to the chain code, and all the time they are creating channels, that this will be a efficiency disaster. So these are the solutions that are easy to do in Hyperledger Fabric. But still, you see, the endorsers are the parties who can see the data, because whenever you are submitting a transaction, they are going to receive it, and then they disseminate it peer-to-peer in a gossiping protocol. So what if you want to trust no one? Because the host of the endorsing peer does have the access. So you want to avoid that. So you will go to the next level, or the next solution, which protects the user anonymity, like who is performing this transaction, who is endorsing this transaction, and the user level credential details, and the unlinkability. So we want to make sure all that in one solution. And the solution is in the usual transactions, when, for example, you try to access any website, you have some certification authority, and you will you can easily check a certificate from them. If I can do that, let's see a very simple way to do it. Let's go to Amazon, and with Amazon you can just click on the lock icon in the Amazon.com, and you will see certificate is valid. And this certificate is issued to Amazon.com, issued by DigiCert Global CA G2, and it is valid from 26/4/2021 to 26/4/2022. And if you want to see whether this particular authority who issued me the certificate, whether this particular authority is a valid one, so let's see. So you can check the certification path, and this DigiCert Global Root G2 is basically the root authority, and then he permitted this second level authority, DigiCert Global CA G2, to allow to issue certificates to other parties, and then this party issued a certificate to Amazon.com. So this is the scenario when you want to check if someone is certified, and that's where this HTTPS role comes into. So you can always make sure that the certificate, the websites that you are visiting, they are safe. So what happens in the Hyperledger Fabric if you don't want to use the user privacy scenario? You can always do that. You can have this X509 certificate, the standard one. You can see with whom you are transacting, and you can make sure that the party has a valid certificate issued by the certificate authority. Because as I mentioned before, the certificate authority is going to issue an enrollment certificate to all the parties. So with this X509 certificate, we are not convinced that the user privacy is maintained. So another solution that is proposed is IDE mix, which is an identity mixer. And what this identity mixer will do, the certificates that you are receiving from the certificate authority, the chain will be like one certificate authority is going to issue the certificates to the next party and to the next intermediary and so on. And ultimately, this certificate is being issued to your organization in which you are an employee. And this certification authority who is basically receiving these certificates is somewhat like a membership service provider who will further issue you certificates like whether you are a program manager, or some team lead or whatever. So with this sequence of certificates, what we see, we always have a valid certificate when we are submitting a transaction, and our administrator is again having a valid certificate, submitting the chain code to the endorsers, and then with the transactions we are just updating the ledgers, making queries to the ledgers, and so on. So what IDE mix will do, the certificate that you are receiving from the certificate authority or the membership service provider in your own organization, this certificate will be created in a new form, and this is a one-time certificate. So we call it transaction certificate. So this transaction certificate, which is one time, will be submitted with the transaction, and whenever the endorser will see, he will check, okay, that the certificate is derived from the certificate authority certificate, like the T-cert, which we see here, the transaction-based certificate, is actually derived from the enrollment certificate, which was issued by the certificate authority. So the endorser will see, okay, this is a valid certificate, and let the transaction be endorsed and signed and submitted to the orderer. But how actually this happens? There is a crypto primitive, a very important crypto primitive, which is known as zero knowledge proof. We try to make sure that hiding our identity as a user or as a transaction submitter, we will submit a zero knowledge proof that I have the valid credentials. If you are not aware about the zero knowledge proof, let me summarize it for you. In zero knowledge proof, this is a protocol between two parties. One is the prover who is proving something, and one is the verifier who will verify whatever you are claiming. And zero knowledge proof protocol facilitates that a party who wants to prove something to party A wants to prove something to party B and claim that I know some value X. So the verifier will get not more than this information. That means the verifier will receive only this information that the prover knows some value X. And this seems impossible, but there are a lot of applications and a lot of research in this field which makes it possible. And this is a bit complex mathematical topic. But the conclusion is, for example, with example, it will be better to understand it. Let's say you want to buy some liquor or some cigarette, and you are not allowed until you are 18. So what you will do, you will go to the store, you will ask for the cigarette, and they will ask for your ID card or whatever proof that can prove that you are above 18. And if you can just provide them a proof that you are above 18 without disclosing your name, without disclosing your age and any extra information other than the proof that you are above 18. So this is doable. Seems in the first, who is listening at first time, it seems like impossible thing. But with crypto, with this complex mathematics, this interactive proof is doable. So these days, like if I talk 10, 20 years back, this particular topic was not very much highlighted or very much researched. But in the last few years, and especially in the context of blockchain privacy, zero knowledge proof is one of the most important pillar, and it can prove most of the things without sharing any information about it. So you will provide a zero knowledge proof that you have some secret and you have some credentials, and the verifier will verify the proof, but there is no other information with him. So IDE Mix basically proposes a different type of certificate, which is T-cert, and they call it presentation token, which is unlinkable. So we are making sure that we are generating a new identity kind of thing from the original certificate, deriving a new certificate by which the other party can make sure, okay, you are one of the team lead in this company, but I don't know who you are. But because you have the authority to submit this transaction, you are allowed to do that. So this is the scenario. So the certificate that you are providing can be easily verified, and as I mentioned, these are known as presentation tokens because these are one-time tokens, and they are always generated with the same credentials because your real identity, your real designation is not changed for all the transactions. It is the same, but all the time when you are generating a new certificate, it uses some randomness, so it's a new one. So the linkability that we wanted to achieve, this can be achieved with this phenomena. And in this system, it seems all the transactions are from different users because they are with different identities, and hence the fact they can achieve anonymity and linkability together. So with IDE Mix, if I summarize, you use anonymous credential systems. This had some, as I mentioned, complex mathematics, uses some blind signatures, some zero knowledge proofs, but ultimately that's doable. So you use anonymous credential system, allows participants to submit transactions while revealing only the attributes necessary to authorize that particular transaction. As I mentioned, whether it is a KYC check or some other attribute that you want to hide. If you are a registered voter, you want to just claim that I am a registered voter, I don't want to disclose my identity. That's doable with the solutions. So this is the one solution which is implemented in Hyperledger Fabric. Of course, this is optional because this is indeed some additional computational cost, communication cost. So the throughput, overall throughput will be definitely less. So if you really want to achieve user privacy, then this is one of the solutions. But there is still one issue, which is all the credentials in the system are issued by the same central entity. And the solution for this is in the real scenario, if you see, there are different organizations, they have their own management systems, and they will allocate your identity as per their system. And the same central authority or the single root certificate authority, as I show you in the Amazon.com scenario. So that's quite impossible, because if you want to maintain the decentralization, you cannot say that every entity who is receiving these certificates from the same central authority, and this, when you are verifying these certificates, it will come back to your organization. So because the certificate that you are showing to other party, which is signed by your membership service provider, and this membership service provider is the party who is issuing certificates in your organization. That means all the transactions can be directly related to your organization. You are indeed hidden. Whenever you are submitting these transactions, your real identity, your transaction certificates will make sure that you are hidden, but among some other attributes. But still, your membership service provider identity is leaked. So the last solution here is the delegated anonymous credentials that will make sure that the certification hierarchy that we can follow, that can be anonymous. And in that case, the endorsing party will see, okay, I received a transaction certificate which is verified with the public key of the certification authority or the root certificate authority, and I don't know from which organization I received it. So if you want to be fully anonymous, then this can be one solution. This is still not included in the fabric, but there are some research done on this issue. Okay, I have some more time, so I can introduce you some permissionless blockchain. So in the permissionless, if you see, one of the most important one is Ethereum. Ethereum supports smart contracts, and you can write the business logic in with the help of these smart contracts. So it has a lot of functionality, can support a lot of applications. So again, the previous is important in all the blockchains. So if we talk about privacy in Ethereum, so it's not anything better than Bitcoin, because it again uses the same system, same proof of work, relying on the same thing, but additionally supports smart contracts. So the privacy in Ethereum and Bitcoin can be more or less similar, because you just rely on the pseudonym. So what people did, they forked Bitcoin. Because the source code is open source. Even the source code of Hyperledger Fabric is also open source. You can just pick it and fork it. So you can just so people fork the Ethereum source code and Bitcoin source code, and they managed to derive new currencies with different privacy features. So one of them is Monero, which is one of the famous ones. Then we have Gcash and Dash and many more. So different features, you can just pick any cryptocurrency, which is open source available. You can add a different consensus mechanism. and you can say, okay, I have a new blockchain or new cryptocurrency. And that's why we have like more than 4,000, 5,000 blockchain, 4,000, 5,000 cryptocurrencies. This is the main reason, because most of the cryptocurrency source codes are available. You can just add something new, and that's it. So with Monero, this is a digital, decentralized, and private cryptocurrency. They completely claim it fully private, but there are some attacks again on Monero as well. And the idea of anonymous transactions started by Bytecoin. So Bytecoin was the first cryptocurrency which thought about adding privacy to the cryptocurrency. And the protocol that they followed was Cryptonaut. So it facilitates these hiding the sender, hiding the receiver, hiding the amount. So main focus was on that. And then they took the source code of Bytecoin and then they further made Monero. Started in 2014. I found this diagram. This is an old picture, found it from the internet. But if you compare Monero and Bitcoin, not all comparison is good enough to compare, but okay, let's see some facts. So the blockchain protocol, they both use proof of work. The usage for both is cryptocurrency, so they say digital currency. In the privacy terms, the Monero claims untraceable. Bitcoin is easily traceable, and this is not trackable. Monero is not trackable. The cryptocurrency they use is XMR, and here they use is BTC. The algorithm, as I mentioned, Cryptonaut was the main algorithm, which was firstly used by Bytecoin, and then they further forked from Bytecoin and then improved it, made Monero. The block timings and some factors might be changed in the last few years, but if you want to understand any permissionless cryptocurrency, then Bytecoin, Monero, Gcash, Dash, these are the famous ones you can start with. So for the sender anonymity, the anonymity of the sender is maintained by ring signature. This is again a crypto primitive. So just in brief, a ring signature has multiple parties included in the signature. It depends upon your choice, how many you want to choose. Depending upon the number of parties, the size of the signature, the verification time, signing time, this all might be different. But what you have to do, you need not to tell them that you are creating a ring signature using their public identity. But in the verification, their public identity is needed. So what you are doing, what you are achieving with the ring signature, you will produce a signature which includes multiple parties, and you are hidden among them. So when someone verifies this ring signature, he will say, okay, this signature was generated using this n number of public keys, and the signer is one of them. So if you see this in the cryptocurrency system, you are submitting a transaction. The standard size that Monero uses for ring signature is 10. So there are 10 signers in each transaction. The receiver will say, this transaction is made by one of the 10 signers, but you don't know exactly who did it. So your identity is totally hidden. If you want to increase the anonymity, you have to a little bit compromise with the efficiency, and you can increase the size from 10 to 20. Your anonymity will be double. So it's up to you how many transactions you want to do in a second or in a minute. Depending upon that, you can modify your algorithm. You can make it more complicated in terms of ring signature, and your anonymity will be maintained in respect of that. For the receiver anonymity, they use one-time addresses, and they call it stealth addresses. So this is all the time when you are sending a transaction to someone, it will be like a new address for the receiver. So you cannot link all the time that these transactions are being received by the same party. For the confidentiality, they use they have a concept like ring confidential transaction. They call it ring city. It again uses some complicated mathematics, which is again from crypto. It uses some zero knowledge proofs. It uses some commitment schemes. So who are familiar with crypto, they should definitely read these concepts and try to make some modifications and make some new cryptocurrencies. For the, as I mentioned in the when we were talking about Hyperledger Fabric, whenever you are submitting a transaction, you are trying to hide your identity with new transaction certificates and so on. But still, there is one thing which we didn't talk about. All the time, you are using some network, and this network is having your IP addresses and all the information, and this should be protected as well. So this is one of the important concerns. But most of the current work, most of the current work, not all, most of the current work do not support this type of privacy. But in Monero, they have this for the transaction broadcast, they have I2P router. And this is more or less like facilitating like Tor or the onion routing that we use in Tor. So this is how they are preventing others to know what you are transacting, how, with whom you are transacting, and so on. And to make sure that you are really anonymous, because if you see, as I mentioned, your social networking traffic can reveal your real identity if your IP address can connect it with that. So that the network anonymity is also important. If you talk about Gcash, Gcash is fork of Bitcoin, and it supports two type of transactions. One is transparent transactions, and another one is shielded transactions. With the shielded transactions, you want to make sure that again, all the features that we are talking about, the privacy features, sender, receiver, and amount of the transaction, they are protected. And the main concept that they use is zero knowledge proof. In crypto, it is known as GK snark, and this GK snark is zero knowledge succinct non-interactive argument of knowledge. So I definitely cannot go into detail about it, because this is something complex and it needs time to understand. But if you see, the basic idea of zero knowledge proof is you want to prove something to someone without disclosing anything about whatever you are claiming, except the claim. So as these GK snark proofs are especially designed to be short proof. But again, the main problem in GK snarks is the proof needs to be produced after some ceremony, and this ceremony is known as the generation of the common reference string. So maybe I'm going too much into new terms, but this is it. Like, we cannot avoid it. So whenever you are initiating these protocols, the zero knowledge proofs or the GK snarks, what you have to do, you have to generate a common strings which is provided to both the parties. And for producing this string, you have some randomness and some trust. And this trust is on some party that you are making. For example, this is some trusted third party. This seems unusual in the blockchain sense, where we say we are decentralizing, we are not trusting any single party. But generation of this common reference string needs to have a trusted third party who can generate this string. And maybe even this is doable, that after generation of the string you can just delete it after providing it to the sender and receiver. But ultimately this is relying on some trusted party. In Gcash, what they did initially, this was the scenario, but later on they added some new feature which they call parse of tau. And with this, the generation of this common reference string was being done by not a single party, but by multiple party. And if you want, you can search on YouTube, and you will find an interesting video in which these multiple parties are at different locations. They are generating these their own share, and these shares are then combined to finalize a common CRS. One of them is flying in the plane, and another one is in an isolated location. And before doing that, they removed all the communication system from these machines, like the Bluetooth, Wi-Fi, and so on. So they wanted to make sure that this ceremony of producing this reference string or producing the randomness, it should be very strictly public, and so that people can trust it, and by multiple parties. So this was done by Gcash, I think 2 or 3 years back. But if you are really interested in Gcash, you can see one interview on YouTube. And this is one of the founder from Gcash, and he claims that the zero knowledge proof that they were using in the initial days, it had some mathematical flaw, and billions of dollars were on stake, because with this mathematical flaw in the zero knowledge proof, you can actually generate counterfeit currency. And when they identified it, it was very difficult to solve it. So it took some time. But you see, for around 10 months, this particular cryptocurrency was vulnerable to this attack. And there were few people in the same company who knew about it, but they tried to make it hidden from the general public. So you have to make sure that the cryptocurrency that you are investing with, it had some good features, well experimented, and so on. So this is a risky business, so make sure that you have all the details about it. So in Gcash, the shielded address to transparent address, if you are making a transaction, then it reveals the received amount. But if you are using the transparent to shielded address transaction, then it protects the received amount. So they have this feature. So you can make a transparent transaction or a shielded transaction, depending upon your choice. So if you see what we talked about, we see what is privacy, what is the role of privacy, especially in blockchain scenario. Explored the privacy solutions in Hyperledger Fabric, and then we see some solutions in Gcash and Monero. I didn't go into detail about Monero and Gcash because these crypto primitives that we use here, whether it is Ring CT or the zero knowledge proof GK Snarks, they are literally a bit complicated, but that's why I didn't include them in the slide. Another solution that we see, like from the practical point of view, to have a trusted execution environment. This is like the enclaves or the enclosed systems where you can make your transactions, and even the machine which is running this enclave cannot extract data from it. So these are the execution environments. Some people call them TPMs, trusted platform modules. Some call it trusted execution environments. And in this small chip where this environment can be produced, you can trust on this. You can provide some raw data to make some computations within it, and the data that you are submitting, the data that you are the computed data that you are receiving is just this is only accessible to the TPM or TEE machine, the component only. And if you run the chain code in this hardware assisted TEE or TPM, then this kind of confidentiality that we are looking for, because if you see, I started my slides with the complex issue of transparency versus privacy. So here you can have privacy provided by this hardware component, and you can run the chain code within it. Even the endorsing peer who is running it doesn't have access to it. So this is only accessible to this enclave itself and no one else. So there are many such chip providers in the system. Intel is one of them, and Intel provides software guard extension, which is Intel SGX. It allows to create a reverse sandbox that protects enclaves from operating system, hypervisor, BIOS, firmware. Like as I mentioned, it is inaccessible to any of the other components in the system. The benefits are it is more efficient than GK-SNARK. GK-SNARK is more efficient if you see the solutions that they provide in Monera. So GK-SNARK was the solution introduced in Gcash. So this is more efficient than GK-SNARK, this trusted execution environment, and it can support arbitrary computations. In GK-SNARK, that's not possible. And it offers guarantees for both data integrity and confidentiality. But the problem is the hardware, instead of cryptographic-based security guarantees, you need to trust, again, a centralized party, which is Intel. And there were some attacks, very well-known attacks, Spectre and Meltdown, on the processors of Intel. So again, if you want to go into this environments, trusted execution environments, then you have to trust the party who is designing them. So again, centralized. One another solution that we can talk about is homomorphic encryption. Again, crypto, and this homomorphic encryption says you can do the computations on the encrypted data, but this will be a bit expensive. If you want it to be more expressive, that means you want it to be more supporting to more operations and more queries. That means you want to make it more expressive. Then you have to use like partial homomorphic encryption. This is efficient, but limited functions. Want to make more expressive, then you have to use fully homomorphic encryption, but with high overhead. So these are the solutions that we currently see in the blockchain scenario. And I think that's it. And now we are open for questions.
Participants, if anyone is having any query, you are open to ask a question. You can either type in chat box also. So we have one query. Does blockchain technology really align with the fast-moving innovations whose prime focus is to optimize memory requirement and execution time?
Okay, good question. So with blockchain technology, it depends which particular blockchain system we are talking about, because as I mentioned, the basic system in blockchain has different components. The components are, hash functions, Merkle tree, and then you run some consensus algorithm, which might be quite complicated in some sense, depending upon which one you choose. And if you talk about saving some memory or some execution time, there are some solutions. There are thousands of transactions that can be supported by one blockchain. Even there are some, even Hyperledger Fabric can support like multiple, maybe tens of thousands of transactions per second. So depending upon which technology you choose, which consensus mechanism you choose, and to how many nodes you distribute your system, you have to replicate the smart contract or the chain code on these number of nodes. They have to maintain the ledger, and ultimately, because the ledger is growing all the time, in Bitcoin, it's already hundreds of gigabytes, I think more than that. And in all of them, this will be the scenario. So depending upon how you design it, it will be done.
Participants, any other queries?
I receive a direct message with a question. Maybe I can say it publicly so we can have a discussion. So I've been told many times that blockchain can be used for purpose like keep data of citizens and their information like income and education and many more things. How can it be done? Gaurav, do you want to answer? Or I do that, or I do it?
Sorry, I missed it.
Okay. We have been told many times that blockchain can be used for purpose like keep data of citizens and their information like income, education, and many more things. How can that be done?
Of course, that's doable, but in my understanding, I would say the technology needs to be a bit more mature to handle that. Because if there is a new blockchain that you are planning to introduce, if that's a permissionless, then we have this attack of like 51% stake and so on. If we are talking about permissioned blockchains, it is more or less like a distributed ledger. Maybe then you want to add something?
Not really.
So there's one more question. For a starter person, how can we add nodes in our blockchain? That's a
Okay.
question.
You have to convince people to run your nodes, because if someone is interested in Bitcoin, he will run a node of Bitcoin. If someone finds more mining fee in Ethereum, maybe he is interested to run a node of Ethereum. So depending upon what incentive you are offering to the nodes, people will be interested to run your node.
I want to tell that for Ethereum, for example, some companies provide renting of nodes. So basically, they allow you to use their nodes and pay for the usage. I can't remember by heart the name of the companies, but that exists. So that's a solution in your situation.
What are the basic requirements for a node server?
Companies provide
What are the, yes, go ahead.
Requirement for a node server?
It is really going to depend upon which blockchain you are running, in fact, because since they all have different features and properties, they will have different requirements.